All right, we'll get started then. Pull this down. So this is Stats 12. I'm your instructor, Miles Chen. You guys can call me Miles, that's fine. And I just posted the syllabus up last night. Should be straightforward, but we'll go over that. Alright, so yeah, so that's me. We meet in this classroom. Obviously you guys found it Monday, Wednesdays, Fridays, 11 to noon, and you guys have section either from 4 to 5 or from 5 to 6 on Mondays and Wednesdays. The Monday part will be a lab, and the Wednesday part will be your discussion section. Your TA is Aroma Lynn. She's very good, so you guys are in good hands there. That's my email address. You can contact me. Right now, my office location is being shifted around, so as soon as I figure out where my permanent office will be, I'll let you guys know. Okay? This is the textbook. You guys will need the textbook for the class. And you don't need any supplemental stuff, just the physical book itself. I'll provide everything else that you need. We're going to have tests on these days. Okay, so there's going to be a good number of tests, almost one every 2 weeks. There's going to be 5 tests throughout the quarter, and your grade will be such as this. Okay, so the tests, 15% each, are referring to exams 1 through 4. Maybe I should specify that. Okay, so exams 1 through 4 will be 15% each. Final exam will be 25%, with attendance, homework, and labs each worth 5%. Yes?
Just a question about the non-lab discussions.
Okay.
How flexible are those? Like, if we're signed up for one, can we go to the other, or is it just go to the one that you signed up for?
I'll leave that up to Aroma Lynn's discretion there, okay? I personally don't have a problem with it, but there just might be issues. I know that the 4 to 5 section is more desirable than the 5 to 6 one, and so if everybody tries to go to the 4 to 5 one, there's just not going to be enough seats for you. So I'll leave that up to her, and she might say, go away. Okay. As for the lab, you have to go to yours because we have only a certain number of computers. So that's that. Okay. So attendance will work, and I'll just take attendance on arbitrarily selected days, either here, or I'll have my TA take attendance as well, and you have to be present. So even if you have a good reason for missing class that day, if you're not there on the day attendance is taken, you don't get credit for attendance. Okay. As for homework, I've posted homework assignments already. Just not all of them, but I'm still working through them. I'm just going to assign. So tonight's homework is very easy, and I'm going to assign homework almost on after every single lecture, almost. And it's just going to be a few topics or a few problems each time. And you're supposed to do these, okay? I'm not actually going to physically collect homework or grade homework or things like that, okay? So when you click this quiz, what it's going to look like, actually, the first one's a little bit different from most of the other ones. So on Monday, you will get this assignment, okay? And it says it's due before class on October 8th, which is Wednesday. You're going to click this. And it's quote-unquote a quiz because that's how CCLE grades it. but basically you're just going to click in, and there's one question, and it says, I have completed all of the assigned exercises, and you are going to select true or false, okay? And I'm expecting you to be honest here. So I recognize that this system is open to abuse here, but I am trusting you in that I give you the homework, you're going to do it, you're going to click true because you did it, and you'll get credit that way, all right? That way there's not all of this paper shuffling back and forth. You can keep your homeworks organized yourself in your own notebook, and refer to them as you study, because in all honesty, the exams themselves are going to be very similar to the homework. So if you can do the homework just fine, you should be just fine for the exams, all right? That said, statistics is not incredibly challenging, but there is a lot to cover. We're going to cover a pretty good amount of this textbook in this quarter. But before I get into that, so anyway, that's how the homework works. Are there any questions about that? Yes.
So if we put false, we wouldn't get credit for it?
Yeah, you will not get credit for the homework assignment, right? So if you answer true every week, you will get your full 5%. If you didn't do homework one day and you click false, you will not get credit for that thing. And there's going to be, I don't know, 20-something, 30 homework assignments, and so it will make a very small difference on your in your final grade. Okay. Is that okay? Can I trust you guys? You guys aren't going to take advantage of me, or take advantage of my trust, I should say. Okay. I'm trying to find a good balance of the amount of homework to assign you and the amount of work and the pacing of this course. If this was the only class you were taking this quarter, I would have no problem assigning the entire book and all of its reading and all of that. I think it would be a fair amount. But I know most of you are probably taking, well, you're required to take at least a total of 12 credits, and probably many of you are taking many more than that. And so I recognize that that you have other things to do on top of your academics, and so we'll try to balance. And if the amount of homework I'm giving you is unreasonable or things like that, just let me know, and we'll try to tweak the pacing of the course. Okay. I've taught intro stats many times, but this is my first time using this particular book, so there is a little bit of adjustment myself. Okay. All right. So anyway, that's how the homework works. You're just gonna click true and say I did it. Okay. Of course, do it. Lab assignments we'll work on that as they come, and you have exams, and this will be our tentative schedule for all the topics we're covering. All right. If you miss a homework or you forget to click, open up the quiz by the time it's due. That's it. There's no makeups for that. And if you miss lab and you don't turn in your assignment, no makeups for that. Exams, I'll only provide makeups if you have a documented good reason. Okay, and I leave it up to my discretion for whether your reason for missing class was good or not. Okay, because I've heard all sorts of reasons. All right. Any questions? Yes.
Regular calculator, fine.
Okay, so let's talk about calculators. I recommend definitely at least a scientific calculator. Okay, so this is the calculator I use. If you've got a scientific one, that should be good. I highly recommend any calculator that has an answer key on it. So look at your calculator, see if there's an answer key somewhere on there. It might be you might have to hit shift or the second button, or secondary function button. And that's that. Graphing calculators are fine. This is fine. Cell phones, tablets, those types of things are not okay. All right. It's fine during class lecture that you can use cell phones for calculators, whatnot. But on days of exams, you are not allowed to use your cell phone. Okay. Okay. Any other questions? Yes.
And the exams all occur during our lecture time?
Yes. Exams will be right here, 50 minutes in length or 45 minutes in length, and they'll be right here. Okay. So about one every 2 weeks, and then the final exam. Yes.
Does the letter size sheet of notes apply to the final as well?
Yes, yes. So on exams, you'll get to have a sheet of notes, like a note sheet, and and you'll use that. So put down your formulas, example problems, things of that nature on there, and you get to have one for every test, and also on the final exam. So you'll probably want to do some revision. The final exam is going to be cumulative with an emphasis on the stuff covered after the last exam. So you'll probably have to go through your old ones and figure that out. Yes?
Do we need a clicker for this class?
No. And can you guys in the back hear me okay? You guys are okay? Alright, I was going to use the microphone, but apparently I have the wrong frequency, so I'll have to ask about that. Alright, I'm recording video, and so don't miss class, but in case you do, or if you need to review, you can view this video online. I'll try to get it posted to YouTube and then post a link on CCLE. And that's so, you know, life happens and you miss class. And we're going to cover about a chapter or chapter and a half or chapter or two every time we're in lecture. So it is a swift-moving course, and so if you miss class, I don't want it to be so detrimental, okay? Now, I understand life events happen, but I hope nothing too terrible happens in your life this quarter, and you'll be able to keep pace with the coursework. Okay? Does everyone already have their textbooks? No? Okay. So you're going to get some homework tonight for this weekend. The first one, actually, you can do all the problems in CCLE itself. I've linked to the applet, which technically is only for the students who bought the access code, but they don't like password protect anything. So if you have the link, you can open up the thing. So I've linked those. I hope I don't get in trouble or anything like that. So you can do your homework easily online, but get your book ASAP, all right? And because starting Monday, you're gonna have to use the book to do the assignments. All right? Okay. All right. So introductory statistics for what is it? Geography and environmental studies. To be honest, I'm not entirely sure what makes this class special from the other introductory statistics courses. We will do a few examples, I guess, in lab that are geography related, but the topic of introductory statistics is introductory statistics, okay? It would, to me, saying introductory statistics for geography or introductory statistics for life sciences or whatever, it feels like saying American history for math majors or something. I don't fully understand how it goes. But that said, I love teaching this class. I love teaching introductory statistics. When I took statistics as an undergraduate student myself, that class literally changed my life. I was studying engineering, and after I finished my engineering degree, but after my statistics class I took more and I fell in love with the subject, and here I am teaching statistics and pursuing this as a career. So anyway, I hope that that you will kind of enjoy the subject matter. All right. Anyone already taken an intro stats class? Okay. All right. Good. So most of you have not, and so I get to introduce you to the topic. All right. Okay. So let's talk about what is statistics in the first place. All right. So why would we bother studying statistics? So I propose that we study any subject, math, biology, chemistry, geography, environmental science, whatever it might be, even history, literature, all of that, to get a better understanding of the world around us, to get either whether we understand people, their thoughts, how things work. We study any subject to help us understand the world around us. And in particular, each subject offers something that maybe a different angle or a different perspective on how to understand our world. So what statistics offers, so let me write this down. By allowing us to make conclusions, limited data. Let me just make sure I'm setting this one here. Just viewing the boundaries of my media screen here. Is this legible enough for you guys in the back? We're good? All right. Good to. Thank you. I love it when people give me thumbs up. You don't have to say anything, but it gives me enough feedback to know that we're okay. And can I write as low as here, or is this going to be troublesome for those of you in the back? Down here? Good? Good? Okay. All right. Excellent. This is an excellent classroom. All right. Allows us to make conclusions from limited data. And what I mean is this. In our world today, we are generating lots and lots of data. Data being information about things, usually organized in some kind of way. We are each generating lots and lots of data. The very fact that you own a mobile phone is generating tons and tons of data about you. Every little app that you open, every click, everything that you do is generating data. And someone else is gathering it. And that said, despite all of the information that we are generating, there's still a lot of information we don't know, or there's still a lot of information that's difficult to obtain. Let's say I ask a simple question. What is the height or what is the average height of an American male? Any guesses as to what the answer to that is? Yeah, what's that? 5'10"? Yeah, that's about right. About 5'9.5", 5'10", something around there. Okay. Now, is that the exact answer? How can we get the exact answer? What would be the one theoretic way to get the exact answer to this question?
Measure all American males and then take the average of it?
Yeah, so we
can't
would
do
have
that.
we would have to measure the height of all American males. So there's 300 something million people in the United States. We can assume about half of them are male, and so if we say those are the American males, we would have, over 150 million people and their heights to measure, and then we would take all of those measurements and then take the average. So we would have 150 million numbers to add up, and then we would divide by 150 million or something to get the average. That is the only way to get the true answer to this question. What is the average height of an American male? And it would be a very precise answer for a very brief amount of time, because probably if somehow we were able to get that measurement, as soon as we get that number, some of those males would have died and new males would have been born, and so our answer would already be outdated. And also in that time, males would have grown taller or whatever, shorter, whatever it might be. And so this is practically impossible to get the true answer, and so we have to deal with kind of an estimate based on limited data. Okay, so if we want to answer this question, I'm going to say it is practically impossible and practically in the literal sense of it is impractical to do this, practically impossible to obtain this result. Which would require measuring the height of all American males. So instead we're dealing with a situation where we take a sample rather than looking at everybody. Okay, so we study a sample, which is a select group from population. And based on what we see in the sample, we want to make conclusions about the population. Okay, so let's say I get some money to do a research study, and for some reason I'm still interested in this question. So I find 1,000 volunteers, 1,000 male volunteers, and I measure their height, and I take the average of those 1,000 male volunteers. Would that provide an answer or information about the average height of the American male? Okay, some of you are shaking your head no. Some of you just have blank stares on your face. That's okay. Well, all right. So let's say I go around UCLA's campus and I get 1,000 males. All right, and I'll say, "Are you American?" Just to make, I don't know, because for some reason I specified American males. Okay, and we get the heights. What is that? Does that tell me anything about the average height of an American male? Yes, no? Why not? So those of you who are shaking your head, no. Yes?
It's a very small sample.
Okay, very small sample, and then
Particular age group.
particular age group, and
It also depends like where to get the sample from. Like if you took a bunch of people from like the basketball team,
Yep.
that'll kind of skew the results.
okay, so these are all very good points. Okay, so actually the fact that it's 1,000 people and that being a small sample is actually not as critical of an issue. We will learn that later on in this course, that 1,000 people can give us plenty of information. You can even take a sample of 30 people, and that will probably give us a good amount of information about the average height of an American male. But these other points of where our sample was taken from, these actually make a big difference, okay? Yes, when we go around UCLA's campus, we are interviewing only a certain age of students or age of people. And so the height of people attending UCLA or at UCLA is not representative of the United States as a whole. Okay, and so the answers that we draw from that sample will also not apply. In terms of, yeah, whether it's from the basketball team or other parts of campus, that will also play an effect. Okay, UCLA itself, the demographics of UCLA are not representative of the United States in any sense, okay? UCLA represents people of above average intelligence, to say the least, okay? And believe it or not, that is, people believe, well, statistically, there seems to be a relationship between that and height. The demographics in terms of race and ethnicity also are not representative of the United States. Okay, disproportionately there are many more Asians and Caucasians than other racial groups at UCLA as compared to the rest of the United States. And so the results that we would draw from maybe UCLA's campus, even if that sample of 1,000 people was representative of UCLA itself, those conclusions cannot be applied to the United States as a whole. Okay, and we will discuss many of these aspects as we progress further in the course. Okay. So let me just give you a brief insight as to where we will be headed in the class. So it says, based on what we see in the sample, we want to make conclusions about the population. Okay, so as we move forward in the class, we're going to start off with just learning about data, how to describe data, all of this stuff, just descriptive statistics, okay, data, describing it and understanding what it looks like, okay. And then we will learn about probability. Okay. Now, probability and statistics are often taught together, and there's a good reason for that. Probability helps us understand the nature of randomness, the nature of random chance. So this is okay. By studying probability, we will see that if I flip a coin twice in a row, it would be not surprising at all if both times the coin landed heads. Okay? So if I flip a coin twice and the coin lands heads both times, that would not be surprising at all. However, if I flipped a coin 10 times and it landed heads all 10 times, that would be very surprising. Okay? That's already intuitive, but probability will give us more insight into situations that may not be as easy to understand or picture. And so this gives us an idea of what is likely to happen by random chance and what is unlikely to happen by random chance. Okay? And then we bring these two together, data and probability, into something we call inference. And the idea behind inference is that we see data. We're able to describe data and things like that. We've gathered data either through an experiment or an observational study. Some data has been gathered. And we want to know, could this data result from just the random effects of life? Okay. Let's say somebody gathered some data and they said, this family wanted 2 girls. And they read some article where if you eat a bunch of carrots, you'll have girls. And this family ate a bunch of carrots, and lo and behold, both of their children are girls. Okay, that is the result of this, quote, study. And so does that provide evidence that eating carrots will increase the likelihood of having a girl? No. Why not? Because the family could have had 2 girls whether they ate carrots or not. All right? It's very, very not uncommon. Okay? So it's a very common thing for a family of 2 children to have 2 girls. Okay? It's quite possible that a family wanted 2 girls, and whether or not they did anything about it, they had 2 girls by random chance anyway. Okay? So by understanding a little bit about probability, we can see that the data that we have seen, a family having 2 girls, is not an unlikely thing to happen by random chance alone. Okay? On the other hand, let's say, I don't know, some person claims to be have magical powers of some kind, and they said, you tell me what gender child you want, and I will make it so. And let's say 100 people visit this person, and this person was successful 99 times in terms of determining the gender of the child. Would you believe that this person actually can do something about determining the gender of the child? Okay? Contrary to our understanding of biology and all of that, and it doesn't make sense that this actually works, the data would show that whatever is happening is unlikely to happen from random chance alone. Okay, the fact that this guy was able to determine the sex of a child 99 times out of 100 is far too strange for us to ignore. Okay, and so that was unlikely to happen by random chance alone. And so then we can make a conclusion that maybe this guy is actually able to do something. Okay, and all of that is called inference. And so we will spend a good amount of time doing inference, and this is where I feel lies the heart of statistics. And this idea here, based on making conclusions, I've already deleted it. Making conclusions on limited data. Okay? All right. So, let me say one thing. Okay. I forgot. This is important. So you're going to get homework almost after every single lecture here. Okay? And so I'm going to cover Chapter 2. It's a very short chapter. I'm going to cover Chapter 2 with the rest of our time here. And you're going to have 3 problems to answer from Chapter 2 for your homework. I don't expect you to read all of this book, okay? And what I recommend that when you do the homework, just go straight to the problems and see if you can answer the problems that I've assigned. And if you can, that's great. That means you have you've got enough understanding from the lecture to do the homework. And if you can do the homework, like I said, if you can do the homework without any problems or without outside help, you should be fine for the exams. So I would say just jump straight to the homework and see if you can do it. If you get stuck, if you can't do the homework problem, which is likely to happen, especially in the later chapters, go back into the book, do some reading. There's a lot of example problems that parallel some of the homework problems, and see if you could answer them that way. I will also post solutions to the problems I've assigned from the Student Solutions Manual, which go through detailed explanations, and so please view those to make sure and verify your answers to make sure when you think you understand it, you actually do understand what's going on. All right? Is that good? Yes?
So if we can answer the questions, it's kind of safe to say that we're chilling on the reading. We're not doing the reading.
I would say so. Okay. Now some of the questions are a little bit more conceptual and theoretic in nature, and that might require you to do the reading. But if you can answer those also without doing the reading, then that's great. Okay. And like I said, I guess to my detriment, I'm going to say the exams should be of equal difficulty to the homework. Okay, I think the homeworks can get challenging, and I think the exams will reflect maybe the more challenging homework problems. But if you can do those homework problems, you should be okay on the exams. And if after the first test you're like, that test was not fair at all, we can talk and we'll make adjustments, and I will apologize for that. Okay. All right. So let's dive into chapter 2. Now that we've seen kind of just a very, very brief picture of what statistics, how we can summarize what statistics is about, let's talk about data. All right. And so as for what data is, we have different types of variables, and what's going on here? All right, so data can be just described as information, and generally there is a context to this information, and generally there should be some organization. Okay. When we go out and gather data, our most basic form of organizing data would be with a table. All right, and so if we are looking at the raw data itself, we might call this a case table. So if we went around the classroom and I said, give me your name, tell me whether you are male or female, so your sex, your age, we'll say your height, and hair color. This is what we would have, and maybe our first person is Adam, who is male, 19, is 5'9", has black hair. And then maybe we have Betty, female, 20, 5'6", brown hair, etc., etc., etc. Okay. Well, this is one thing of, and we would have a line for each person. Okay. Each line is considered a case. All right. And in our example here, a case corresponds to a student, a person. Now, if I said, let's gather information about the about each state in our country, and I want to know the population of that state and I don't know, whether or not it voted for the Republican or Democratic candidate in the last presidential election. Okay. All right. In that example, what is each case? Each case is each state. How many cases would I have? I would have 50 cases. Okay, good. All right. So each line is a case, and each column that we have would be a variable. And we have two types of variables. This is very simple. It can be numeric. We have numeric variables, and we have categorical variables. Okay. Sometimes numeric are called quantitative variables, and categorical is sometimes called qualitative. Fans of alliteration. Okay, numeric variables tell us how much or how many. Or they give us a quantity. So in my case table of students and their attributes, which ones are numeric variables?
Age and height.
Age and height. They tell us how many years has this person been alive. How many inches tall is this person? Categorical variables, on the other hand, give us tell us what type or what kind. And so that would be the sex of the student, male or female, or other, and hair color, black, brown, blonde, whatever. Red. Any other category that we want to put in there. Okay. So let me ask you this. If we ask for someone's zip code, is that a numeric or categorical variable? Categorical. Okay, even though there's a number, even though zip code is a number, it does not tell us how much or how many. It does not make sense to compare two zip codes and say, I have 40 more zip code than you. So in that sense, it is not going to be numeric. Okay, so it's categorical. It tells you, I guess, what is the location, or what category zip code are you in, okay? So zip code is categorical, even though it's represented with a number. All right, and when you do your homework, it's going to ask you to identify the W's, all right? So when you learned how to write a story or a paragraph in grade school, you learned about the different W's, right? The who, what, when, where, why, and how, right? All right. I will not try to define what these things are because I think you already know. In essence, the who, when it comes to data, is each case, all right? The cases form our who. So in this example, the who, or another question would be, what is each case? Would be each student. In the other example I mentioned, the who would be each state in our country. So there would be 50 cases or states would be our who. The what are the different variables that we've collected. are the information. These other questions, when, where, why, and how, are important, and these form the context of the data. Okay. So knowing when the data was gathered is important. Okay. Data gathered this year is going to be very different from data gathered 100 years ago. Any types of questions that we could ask, you know, what is your opinion on this subject matter as to when the data was taken will play a very different role. Okay, you know, what is your opinion on gay marriage? The when makes a huge difference, even just from 10 years ago. Okay, the where, the why, and the how also can play a big role depending on what type of data has been recorded. Okay, so what is your opinion on gay marriage? You know, whether you ask that in California or Utah is going to make a big difference. All right.